Welcome to a lesson on exercise 9C, which is all about using formulas. And look, you're familiar with using formulas. We've been doing it probably since primary school. As you move into more advanced maths, however, you need to be more flexible with using formulae. What do I mean by that is, for example, we know a bunch of these different formulae. For example, circumference is 2 pi r. Circumference of a circle is 2 pi r. And the idea generally is to find circumference, you need to have the radius. And Fahrenheit, to get a temperature in Fahrenheit, and you want to convert it between Fahrenheit and degrees Celsius, then you have a formula for that as well. So as long as you have C, you can figure out F. And speed equals distance over time is a formula for finding speed if you have distance and you have time. And similarly, we have CF and S are said to be, okay, so CF and S are said to be the subjects of the formula given above. C is the subject of this formula. C equals 2 pi r. F, Fahrenheit, is the subject of the formula because it's by itself on one side is equal to 9/5c plus 32. Speed is the formula because once again, speed is the subject of the formula. So once again, it's by itself on one side of the equation. On the other side of the equal sign, you have d over t. Now, as you move into year 10, year 11, year 12, we will no longer have simple formulae where, to find C, you'll just be given R. You'll have to rearrange the formula. You'll be given C and you have to find R. And that's really the difference between year 10, year 11, year 12, and, early on, like late primary school, early high school. In high school, in year 7, 8, year 9 as well, perhaps, the question would have been more like the following. The question would have been like, okay, that's a circle, and the radius of this circle is 5. Find the circumference. And then you write down, circumference is equal to 2 pi r. R over here is 5. So circumference is equal to 2 times pi times 5. And that's 10 pi. You put that on a calculator and you got 331.4 something or other, roughly. That's like, in years 7 to 9, perhaps. Whereas in year 10, we have something different. In year 10, you'll have something like this. You'll have, okay, the circumference of the circle, C, if C equals to 33, find R. Find R. And that's the difference. So now you have to know how to rearrange equations. So C equals 2 pi R as before, but now you know C, and we know it's 33 equals 2 times pi times R, and we don't know what R is, we need to find R. So you're going to have to rearrange this equation. You have to divide both sides by 2 pi. So add this by 2 pi, and we divide that by 2 pi, and you're left with R is equal to 33 over 2 pi. And you put that in the calculator and you get R. So there's a slight difference. We're still using a formula. We're still using formula like over here. We're still using all these formulae that we've been using up until now. Whereas in year 7 to 9, you only have to find the subject of the formula and you were given everything else. You were given the radius. Moving in year 10, year 11, year 12, it's more about you have to rearrange the equation, make something else the subject, and then substitute and put in the calculator and so on. So it is getting slightly harder. Is a couple of extra steps required to use the formula. So let's look at an example. If it says if v equals to u plus at, find t when v is 16, u is 4, and a is 3. And just a bit of a heads up, that's not like a random equation. This is actually something that you'll do in physics, I believe, as well as 2-unit advanced maths and 3-unit maths. However, this question by itself on its own, it's very much a year 10 level question, if not a year 9 level question. It's just basic substitution. So let's sub it in. We know what, so we're going to write it out. V is equal to U plus AT. And V is 16, so I can wipe this off and I can write 16. U is 4, so I'll write 4. And A is 3, so I'll write 3. Now, of course, you won't actually do that in your book. I'm just showing you what we're going to do. What you're going to write down is you write down the equation, then you write 16 is equal to 4 plus a is 3, so 3t. Now you have to solve that equation. And that's just building on what we've been doing, right? In the past couple of exercises, we've been looking at how to solve this. So you subtract 4 on both sides, and you're left with 3t is equal to 16 minus 4 is 12. Then you divide both sides by 3, and you get t equals to 4, and you're done. And as you can see, every single lesson, we are building one step more. We're building on what we've done in the previous exercises. So we started off in the first exercise of this term. We started 9a, I believe. We started off doing solving stuff like this. 5t equals to 20. Okay, that's what we started off doing. And then we built up to 5t plus 5 is equal to 25. And then, divide. If you look at the first one, if you divide both sides by 5, you get t equals to 4. Now, we built up to this type of question where you have to subtract 5 on both sides, and then you ended up with 5t equals to 20. But note, this is the same as that question. We've just added an extra step. And then in the previous exercise, in 9b, I believe, we looked at stuff like 5t plus 5 all divided by, I don't know, all divided by 5, for example, is equal to 5. And then what we did was we said, okay, let's multiply both sides by 5. And then we have 5t is equal to 25. And notice that we are 5t plus 5 is equal to 25. And we're back to here. And so we're just adding in a step every single time. And now we have something one step more. It's where you have an equation. You have to sub stuff in first, and then you're back to, the previous lesson type of stuff. So it's really just going to build on from here. However, the basic 4 rules, the core rules, do not change. You can add anything you want as long as you add it to both sides. And we can use this rule to undo any subtraction that is taking place. And you can subtract anything you want as long as you subtract from both sides. You can multiply anything you want as long as you multiply every single term on both sides of the equation. And you can divide by anything you want as long as you divide every term by the same number on both sides of the equal sign. And so let's have a look at, there was only one worked example in this exercise, but I thought I might as well do a few more. So let's have a look at something that's slightly more challenging. For example, it says find m, and you have a bunch of different values here. So I'm going to pick one at random. Can someone put an A, B, C, or D in chat, please? Just anything at random. Which one should I do? Come on, guys. A, B, C, or D? They can. Okay, Zaria has said B, so let's do B. Well, we're trying to find M. So we have E equals to MC squared. You should always start your solution by starting off with your equation. Then you do the substitution. Now, E is 4,000. So I'm going to write 4,000 is equal to C is 10. So you have M, and then you have 10 squared. Make sure you use brackets. And that's equal to 10 squared is 100. So 100 M. 4,000 is equal to 100 M. Now you have to obviously undo the 100. So I'm going to divide both sides by 100. And so M is equal to 4,000 divided by 100. 40 is the answer. And you can always use a calculator. 4,000 divided by 100, use a calculator. And M is 40. And I'm done. That's really all there is to it. And then now we'll look at question 9. We'll do one more. V is equal to pi r squared h. And we have to find h. So before even doing anything, I can certainly do this. Pi r squared h. Now I want to know h. I want to find h to one decimal place. Before in substitution, I can actually make h the subject. And the way I can do that is I can get rid of everything that's with h. So I know h is getting multiplied by the number pi r squared. Pi r squared, I know the variables, but at the end of the day, pi is a number and r is a number. We just don't know what it is. It's r squared, pi r squared. So what I can do is I can divide both sides by pi r squared. Pi r squared. And so h really, and that's going to cancel out, h is equal to v divided by pi r squared. And I know what h is now. And so if I wanted to find h for any of these, let's choose a biggest number like we did in last time. Let's say, for example, it's c. We're going to do for v is 1460. So you have 1460 all over, and then r is 9. So you have pi times 9 squared equals to h. And I could pull out my calculator and I will share my screen. Screen 1. I hope that didn't wreck the recording. Anyway, so pull out a calculator and let's just sub this in. So we have 1460 all over shift pi open bracket 9 close bracket squared pi 9 squared, and h is equal to, it says to one decimal place, and so that's going to be 5.7. H is equal to 5.7. And yeah, so that's it for today. Please get started with the exercise. If you need help, let me know. I'll be available on Slack. I'm also going to be hanging around on Zoom here all the way till the end of the lesson. You should be able to finish now, although you also have period 6 today, so you can catch up / finish off the current exercise. Now, it is important that you pay particular attention to this exercise because, in my humble opinion, most of standard maths, or much of standard maths, and even like half of advanced maths, it's really just a matter of knowing the formula and being able to substitute and rearrange equations. So if you're good at this particular exercise, you'll be hopefully pretty decent with at least standard maths next year in 11 year 12 if you decide to choose it. So please do take it seriously and see how you do. And yes, that's it for the recording.